the disturbing reason your body already feels what's rising beneath Yellowstone. And in 2003, the floor of a lake sitting over a supervolcano heaved upward without warning, without an earthquake, and without a single scientist on Earth who could tell you why. What's pushing from below is not what anyone expected, and it's still moving. Yellowstone Lake looks calm, 2,000 feet deep, 20 square miles of blue water ringed by pine forest. Tourists photograph it. Families fish from its shores. You've seen the postcard, but the ground beneath that water is breathing, not metaphorically. The lake floor rises, it falls, it tilts, it shoves millions of gallons sideways. The rise that started in 1999 lifted the northern lakebed by nearly a meter before it quietly reversed. No warning, no explanation, just movement. The kind of movement that happens when something enormous is awake deep below, something science has a name for but not an answer to. That thing is underneath you right now. Here's what they found when they sent submersibles into the dark. The floor of Yellowstone Lake is not a floor, it's a landscape. Craters, spires of mineral deposit rising 40 feet from the sediment. Hydrothermal vents blasting superheated water into the cold lake above. And at the north end, something called the inflated plain. A dome of lakebed pushing upward faster than almost any geological feature in North America. Researchers mapped it year by year. 1999, rising 2001, still rising 2003, it stopped. Then slowly it reversed. And here is the question nobody has answered since. What made it rise? What made it stop? It wasn't magma intrusion they checked. It wasn't an earthquake swarm, too quiet for that. The best current theory is hydrothermal fluid, superheated water trapped under pressure beneath the lakebed. But that theory has a hole in it, a big one, because here's what breaks the fluid theory. The heaving doesn't follow the heat. Yellowstone's hydrothermal system is one of the most monitored on the planet. Scientists track temperature, pressure, gas output, and ground deformation in real time. And when that lakebed was rising fastest, thermal output from the vents was not spiking. Lake temperature wasn't climbing. If trapped steam was inflating the crust like a blister, you'd expect heat. You didn't get it. What you got was a silent, pressurized lift with no thermal signature. That's not supposed to be possible. Then the lake tilted. The south end dropped while the north end rose. Water moved. Shorelines shifted by inches. The whole lake was slowly rocking, and underneath it, something was breathing in the dark. Go back 13,800 years. You're standing at the north end of what will become Yellowstone Lake. The ground shakes once. Then the lake floor doesn't just heave, it explodes. A hydrothermal blast rips a crater into the earth 1.5 miles wide. That crater is Mary Bay. You can swim over it today. Tourists do. And what the geological record shows is that this type of explosion, not volcanic, not seismic, purely hydrothermal, requires one specific condition: a sealed cap. A layer of cold, pressurized lakebed that traps superheated fluid beneath it until pressure exceeds the weight of rock above. Then it lets go all at once. Now look at what the inflated plain was doing. Rising, sealing, building pressure. Then, at the moment scientists calculate the cap would have been thickest, it stopped, reversed. As though something drained it, or as though the cap held. For now, what nobody can model is the release cycle. How long does it inflate before it blows? How many cycles did the ground run before Mary Bay finally gave way? Because if the inflated plain is following the same pattern as the ground that became Mary Bay, the reversal in 2003 wasn't the end of the cycle. It was the reset. The next inflation started almost immediately. It has been rising again since 2016. A hydrothermal explosion at Mary Bay scale today would not just destroy the lake. The blast column would reach 30,000 feet. Ash would travel 500 miles. And unlike a volcanic eruption, there would be no lava plume on satellite, no tremor sequence building for days, no evacuation window, just the lake and then not. Yellowstone draws 4 million visitors a year. The Park Service monitors the ground deformation. They track the uplift. They publish the numbers. What they don't publish is a threshold, the specific measurement at which watching becomes warning. That number exists in no public document, which means the system monitoring a lake that may explode has no agreed definition of when the data becomes an emergency. You are in the data. You are not in the plan. The inflated plain is still there, still moving. Yellowstone Lake has been tilting again since the monitoring network was upgraded in 2020. Researchers call it normal hydrothermal variability. They've called it that for 25 years. But here's the question none of the published papers answer. If the cap resets on a cycle, and each reset builds more confined pressure than the last, what happens at the end of the cycle? Not the reset, the end. And here is what should keep you awake: nobody knows which cycle we're on right now.